What we're going to do is we're going to review how we determine the empirical and molecular formula of a compound. Now, just a reminder, our empirical formula is our smallest whole number ratio between the atoms in a compound, while our molecular formula is our actual whole number ratio. Okay. Now, if we want to determine our empirical formula, what we need to do is we need to first have the mass of each element in a given amount of the sample. And we can be given this mass in a number of ways. We can be told we have X number of grams of each element, or we could be given the percent composition. And then if we're given percentages, all we do is assume we have 100 grams. We can then take that mass and divide it by its molar mass to get the moles of each element present. Then we can get a mole ratio between all of the elements by dividing by the smallest number of moles present. And then we will look at our mole ratios and see if we have to then change them or multiply them by a factor, or if we can round. So, for example, let's take a look at this question. A molecule is found to have 40% carbon, 6.72% hydrogen, and 53.28% oxygen. So, as we were shown, first we list our elements, then we'll write down our given information, our percents. Then, because they're given in percents, what we will do is we will assume that we have 100 grams of the sample. If we do, then that allows us to say that the mass of each element in that 100 grams is the same as its percent. So therefore, we have 40 grams of carbon, 6.72% of hydrogen, and 53.28 grams of oxygen. We can now multiply each of these by the inverse of their molar mass, or divide by molar mass, and it'll tell us our moles. And so then we can see here that I have 3.33 moles of carbon, 6.65 moles of hydrogen, and 3.33 moles of oxygen. So we'll take the lowest number of moles present, which is 3.33, and we'll divide the number of moles of each of them by that, and we get a mole ratio, a 1 to 2 to 1. And so therefore, our empirical formula for this compound would be CH2O. Now, if we want to know our molecular formula, then what we need to do is we need to first determine our molar mass, or be given our molar mass of the compound, and then we can determine the mass for the empirical formula, which we can call our empirical mass, and then we can determine the number of empirical formula units in my molecular formula. And what we'll do is we'll take our molecular formula molar mass and divide by our empirical formula mass and get our value X, and then we will multiply the subscripts for each of the elements in our empirical formula to get our molecular formula. For example, caffeine, we have our information here. Again, all we have to do is first list the elements present. Regardless of how many elements are present, we use the table format. It'll help us to organize our information. We'll record the percent of each. And then, again, because it's percent, we'll say, okay, what's my mass for 100 grams of each of them? That allows us to convert our percents into a mass. Then we're going to divide each of these masses by their molar mass to get moles. So now I have moles of each element present. And then I'm going to take the smallest number of moles, in this case it would be my moles of oxygen, and I'm going to divide the number of moles of each of them by the moles of oxygen. And this will give me a mole ratio. Okay? And I can look at these numbers and I can see that most of them are close enough to their whole number that we can just round. And so my new mole ratio will just be the rounded numbers. And so therefore, I have an empirical formula of C4H5ON2. Now, I need to take this empirical formula and convert it into molecular formula. So first what I'm going to do is I'm going to determine what would be the molar mass of this empirical formula. Okay. So I would calculate the molar mass for this empirical formula in the exact same way I calculate the molar mass for a molecular formula, where I multiply the number of moles of each element by their molar mass, and I add them up. So now that I know my empirical formula's molar mass, I can then take and divide my molecular formula's molar mass, which we were given, and I can come up with a coefficient. And so what this tells me is that when I went from my molecular formula to my empirical formula, I divided all of the coefficients by 2. So therefore, to go the other way from my empirical formula to my molecular formula, I multiply all the coefficients by 2. And so I get an empirical formula, a molecular formula, for this compound, of C8H10O2 and 4.